Welcome friends to the class again. This course of marketing research and analysis we have been doing for the last many sessions now, and we have covered several important aspects of marketing research. So, currently we are doing the non-parametric test, and why we should be doing it I had explained in the last lecture, right. So, a non-parametric test is a test, as I had explained, is one which does not follow a normal distribution. So, the normal distribution is something like this, like a Bell's curve, and the non-parametric tests are those tests which violate the normal distribution the conditions. So, for example, if the data is, let us say a skewed data, for example, let us take this, although I will be explaining today. So, if the data is a skewed data, or there are lot of outliers in the data. So, we say the analysis that we need to do is a one which violates the normality assumptions, and therefore, the best method is the non-parametric tests. And in under non-parametric tests I had also said there are several tests, for example, the Mann-Whitney U test, which we had started in the last lecture, right. So, the Mann-Whitney U test is nothing but, as I had said, it is very simple, it is a analogy of the t test, independent sample t test. So, if you remember in the while doing the t test, you must have heard of one sample t test, then independent sample, paired sample. So, then when you have more than 2 samples, then you went for, let us say, the ANOVA, right, one way ANOVA. So, there are several tests that we are talking about, and the Mann-Whitney U test is one of the first starting points where we are done with the independent sample t test. Okay. Now, I said I will be explaining you the Mann-Whitney U test at the end of the class, in the last class, through the SPSS also. Okay. So, the software which we are using is SPSS. So, how do I do it on the SPSS? Now, if you can look at this table, right, the data sheet. Now, it talks about there are several variables, for example, x1, x2, this is first is the ID number, then x1 which is the delivery speed, x2 price level, x3 the price flexibility, x4 manufacturer's intention, x5 service. So, similarly all are there. Then up to x7, if you see, the data is measured in a continuous scale, right. X8 is measured in, which is firm size, is measured as a categorical variable, right. So, small firm, large firms, right. So, for example, again going to, if you see the x12, right, x12 is again a categorical variable, right. X13 x12 is a category, x13 is again a categorical variable, right, which is firm type. So, you have some categorical variables in this case. X14 is also a categorical variable which has 3 categories: new task, modified rebate, straight rebate. I think you if you have heard of it in a industrial buying process, we use this language. Okay. So, there are several variables. Now, how do I go for the non-parametric? First of all, you test. First of all, you check whether the data is following a normality or not. Now, how do I check? Now, first I will see, let us say what I will do is I will go to the explore, right, and I will take one of the data, let us say I am taking any one, let us say price flexibility, let us say. I want to see whether it is a what kind of, I want to see a plot, right, and I want to see whether it is following a normal distribution or not. So, if you remember in the last class itself I had said to you, just you can do one thing, you can check the skewness, right, and kurtosis. Now, this is luckily the data is not skewed and it is a normal data, right. But suppose you find some data is not normal. So, I do not have a maybe a data which is we can do one thing, we can check for all otherwise. So, we will take from delivery speed, price level, right, manufacturer's image, surveys, this one and this one, usage level and satisfaction level. So, I am trying to see if these data any of them follows a non-normal pattern or not. So, let us see skewness, okay, 2 4 no, not does this also, 2 4 3 2 4 3 3 6 7 So, I think you remember how we do it. This one, let us say Salesforce image, although it is very close to normal distribution, the skewness is not very high, and just for an example I am trying to show you, just let us imagine Salesforce image. So, if you remember, I told you very clearly that if your data is slightly skewed, moderately skewed, even you can go march ahead. If you have a decent sample size, you can march ahead with the normal parametric tests. But however, if your data is extremely skewed, then only you can go for you should go for a non-parametric test, and even after correction, it is the transformation of the data is not getting a normality, it is not showing normal distribution, then only, right. So, assume for a second this data is not showing a normal pattern, right. So, what I am doing is I am just to show you how do I do a non-parametric test in SPSS. So, you can see this, right. So, I go to the legacy box. There are few things here, chi-square test, which is a non-parametric test, binomial test, runs test, they are all non-parametric tests. Okay. Now, here out of this I am picking up this independent sample test, right. So, what is this independent sample? If you remember, there are two different sample groups, sample 1 and sample 2, and we are trying to check how whether there is any similarity, whether the sample 1 and sample 2 are same or they are different, right. So, so let us say Salesforce image I am taking here, and what am I checking against, what is the grouping variable? The grouping variable is, let us say I am taking x8, which is the firm size. Now, firm size when you take, you have to define the group. Now, look at it. So, I am using from the keyboard, what I will do is I will put a value of 0, and for here I will put a value of 1, right. Now, I do not require this, continue. Now, you see x8 has 0 and 1, right. So, I have to taken this. Now, what do I need here? This exact if you see, this is what I require, right. So, let us go to options, you may use the descriptives, right, continuous, and if you see here automatically the Mann-Whitney U test is selected, right. Okay. Let us say, let us check this. Now, if you see here, it is because you had asked for descriptives, it is telling you the firm size, what is the mean is this much, the standard deviation is given to you. The Mann-Whitney test values are given to you, the mean rank and the number of Salesforce, the n is given to you, the mean rank is given to you, the sum of ranks is given to you. If you remember in the last class lecture where I explained how to measure by calculating the u, if you remember the u value, to measure the u value you require the mean, the standard error and the to calculate the u value, right, Mann-Whitney U value. So, after this is the one which is important to us, the test statistics. Now, if you look at the Mann-Whitney U value for the Salesforce image is 1189. What is this Wilcoxon? This is another parameter always compared, right. So, this is but not important to us. Let us go to the Z is minus 0.074, right, Z value, and it is the significance value if you see is 0.941. So, if you remember from the earlier classes, when you have a significance value of 0.941, why it is a two tail? Because the value can fall either to the left or to the right, right. So, 0.941 means the null hypothesis which said that there is no difference between the Salesforce image in small versus large firms. That means the Salesforce image in small firms is same as the Salesforce image in the large firms. So, this null hypothesis has been is not rejected in this case, right, because it is above 0.05. Suppose I take it at a 5% level of significance or even at a 1% level of significance. So, it is 0.941, which is almost saying they are same. So, in that case we are saying the Salesforce image across the two firms sizes, small and large, they are not different, they are same, right. So, this is what you do in the Mann-Whitney U test. Okay. So, today we are starting with another test which is the Kruskal-Wallis test. Now, the Kruskal-Wallis test is a test which is very similar to a Mann-Whitney test only, but it has more than 2 samples now. So, it is close to as good as it looks like a one by ANOVA, right. So, let us see this. It is a non-parametric test, obviously. It is the extension of the Mann-Whitney test to situations where more than 2 populations are involved. So, here more than 2 populations are involved. This test too depends on the ranks of the sample. So, it also comes under the family of rank sums, it comes under the family of rank sums test, okay, like the Mann-Whitney. So, okay, let us take a problem. So, this is a problem. So, how to solve this, right? The score of a sample of 20 students pilots on their Federal Aviation Agency written examination are arranged according to the method used in their training. There are 3 methods used: video cassette methods, audio cassette methods, or classroom training methods. So, these are the 3 training methods which were used on some students, and then their scores were checked. So, the Federal Aviation Agency is interested in evaluating the effectiveness of these training methods. So, which training method is the best? Is it the first one? Is it the second one? Is it video? Is it audio, or a classroom training? It wants to test at the 10% level of significance. The hypothesis that the mean written examination scores are equal, right, obviously. So, if I ask you to write the null hypothesis, what would it be? The null hypothesis would be H0 is equal to, there is no difference in the scores of the students who use the video method. So, mu video is equal to mu of audio is equal to mu of classroom, okay. Because we have more than 2 population involved, the Kruskal-Wallis test is the appropriate method, okay. Let us see how to do this. So, the first thing is the values in the following table is ranked from lower to higher. In the Mann-Whitney also you had done that, you had done some ranking, okay. Let us see this. Video cassette 74, 88, 82, 93, 55, 70, some values are given, the scores. People who follow the audio cassette method 78, 80, 65, 57, 89, so these values are not known to us. Classroom who follow the classroom method, so this is the values given to us. Now, the question is the score, there is a difference in the score received by the students who followed these 3 different methods. So, null hypothesis is saying at this moment no, right. So, let us check it. How do we do that? So, first we do a ranking. So, 1, 2, 3, 4, 5, 6, 7, 9, 10, 11 up to 20. So, 20 students were there. So, the lowest value, we start with the lowest value 50, and which training method did they follow? In a classroom, right. Second 55, what was the training method? In a video cassette. Third 57, audio cassette. So, we have done a ranking of these people, right. So, all the students have been ranked. So, out of which we can see there are maybe classroom is 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 people were in classroom method, right. So, once we have done it, the ranks are given to you, then we arrange it, right. So, video cassette, what was the score of the student? Now, let us say 74, what is his present rank? The 7, right. Somebody who scored 88, what is his present rank? 15. So, we have done it as per the method video cassette, audio cassette and classroom. 82, one who scored under video cassette method 82, his rank is 12. 93, 19, 55, 2 because he was the second person, right. 76, audio cassette similarly we have done it. So, 78 was who scored got the 9th rank, 80 who scored got the 10th rank, similarly 89 who got was 16th ranked, classroom also you can see, right. Now, what we have done is we will take a total of these ranks. So, 61, this total is 15 plus 7 plus 12 plus 19 plus 2 plus 6 is 61. Audio cassette, this total is 42, 9th rank, 10th rank, 19, 4, 23, 26, 32, 42. Similarly, people who use the classroom method, the score for them is 107. It does not matter because automatically although this scores may be looking little different to you, but the number of if you see the n is also quite separate in all the 3 cases, right. So, what are symbols used? Nj is the number of items in sample j, okay. Rj is the sum of the ranks of all items in sample j. K is the number of samples. In ANOVA also we are using this number of groups and number of columns and number of items within the group, number of how many members were total there. So, within the group how much and between the group how many groups were there. So, these things we are doing. Similarly, total n is equal to n1 plus n2 up to nk, right. So, the k statistics which is to be measured like you measured in the Mann-Whitney U statistics, here we are measuring the k statistics. How is it measured? 12 divided by n into n plus 1, right, into summation of the rank square divided by nj, the jth variable sample j, minus 3 into n. This is the formula, right. So, using this formula, let us see what is the k statistics coming. So, 12 divided by n is 20, 20 people were the students were there, by 20 plus 1 into 20 plus 1, sorry, this much, summation of the ranks. Now, how much? 61 was the first. So, 61 square divided by 6, sample size was 6 for the first, this was I think the video cassette group. Then audio cassette group was 42, so 42 square divided by 5, plus classroom, the total rank was 107, 107 square divided by 9. So, they somehow they have managed by themselves, because the number of it has been divided by the sample size, right, minus 3 into n plus 1. Now, doing this we get a score of 1.143. Okay. So, the sampling distribution of the k statistics can be approximated by a chi-square distribution when all the sample sizes are at least 5. So, this this distribution k statistics is approximated by a chi-square distribution whenever the sample size is more than 5, right. Because our problem meets this condition, we can use the chi-square distribution, you can use the chi-square distribution for a Kruskal-Wallis test. So, the approximate number of degrees of freedom is k minus 1. So, which is in this case is 3 minus 1 equal to 2. So, there are 3 samples. So, in ANOVA also you were doing the same, there were 3 suppose samples, you were dividing minus certain 1 minus 1 from it. So, the hypothesis is mu 1 is equal to mu 2 is equal to mu 3, correct, or alternative hypothesis mu 1, mu 2 and mu 3 are not equal, at least one of them is not equal. What is my significance level? 10%. The acceptance region for the null hypothesis that there are no differences among the 3 populations extends from 0 to a chi-square value of 4.605, right. Obviously, the sample k value is 1.143. Now, if you look at for the for a 10% level of significance, it says the chi-square value would have been maximum up to 4.605, and here our value is only 1.143, which is well within the acceptance region. So, the null hypothesis cannot be rejected. So, therefore, the federal agency should accept the null hypothesis and conclude that there are no differences in the result obtained by using the 3 training methods. Okay. So, this is one important element, because it helps you to compare between groups, 3 separate groups, and test which is the how it is being done and what is the difference between the samples. You can also do it in a different way, as I used to explain, if you I do not remember whether I have done it or not. While doing a ANOVA, you can distribute into paired, for example, let us say sample 1, sample 2 and sample 3 are there in this case, let us say. So, you can do a Mann-Whitney test between S1 and S2, you can do a Mann-Whitney test between S2 and S3, you can do a Mann-Whitney test between S7 and S3, and also see which is the most effective method or the out of these 3, you can do that, right. So, so when you are doing this, but one problem will occur if you do multiple tests, as you do multiple suppose t tests also in case of a parametric test. What happens is the alpha gets inflated, right. So, the alpha gets inflated and that creates an error. So, in such conditions what is advised is that you use a Bonferroni correction test. What is this Bonferroni correction test? That means suppose you take a alpha of 5% and you have suppose 3 tests now S1 S2, S2 S3, S1 S3, then this 5% should be divided among the 3 tests. This is called the Bonferroni adjustment test. Okay. So, when you do this k value test and then you understand well it is more like the ANOVA only, and how whether there is a difference between the groups exists or not. Let me see if I can show you if time permits through the SPSS. Now, so again we go to non-parametric, right. Now, you see here you can see this k independent samples, right. So, k independent samples will be for example, why k independent samples? Because this is more than 2, right. So, independent sample was for 2, but when it is more than 2 it is k independent sample. Now, let us take any one, again the same thing, the Salesforce image for example, and the grouping variable now I am taking is let us say the type of industry. I think X14 is the type of industry. So, what I am defining is the minimum is keyboard is 1 and the maximum is you can see here 3, right. continue. Okay. Do you want anything from here? I think we should follow the normal process. So, if you want to use the descriptives you can use. Now, one interesting thing is you can also check for the median, because why you see, because we have said that the parametric tests follow a median, median is the most strongest parameter of measure of central tendency in case of a non-parametric test, right. But I hope you have understood that Kruskal-Wallis test is nothing but a very similar test like the ANOVA, only condition is this is a non-parametric test instead of a parametric one. Okay, I will wind up the lecture here. Thank you so much.